My name is Tyler Walch. This is Success with DynamoDB through Sensible Key Design. You might know a little bit about DynamoDB. You might know a lot about DynamoDB, but I guarantee there's something for you in this video. This is a presentation I gave at the Atlanta AWS Summit. I'm only going to record this video like once, so it's going to be a little rough. I haven't done this in a while, but I wanted to get it down and recorded. So let's go through it. So this is the presentation right here. You can reach me at TinkerTamper on Twitter. If you have any questions, if I don't get to, I'll reply to you. I also have a library called ElectroDB. It's a node.js library. It's a type-safe way to deal with DynamoDB. It does everything I mentioned in these videos out of the box. So give it a try. Check out the README. Check out the documentation, electrodb.dev, and you can just install it from npm electrodb. So first, we're going to start with an overview of DynamoDB keys. You might already be familiar with this, so don't be discouraged if you're like, yeah, I know that. We're going to introduce a modeling challenge, and we'll use that modeling challenge as a way to iterate on our key design, and we'll go through a bunch of different concepts. So we're going to start simple, ramp up. If you're already familiar with some of this, maybe you read Alex DeBrie's book. It's a great resource. If you haven't, I definitely recommend you check it out. We go a bit further than he does in the book. And so as an intro to DynamoDB keys, you typically would have a partition key and a sort key. You can have just a partition key, but the partition key is required on a DynamoDB table, while a sort key is going to be optional. Partition key is going to impact how your data is actually stored on DynamoDB's backend storage nodes. So you can leverage the partition key to literally partition or co-locate similar data. The sort key is actually going to impact how the data is sorted in terms of the order it will come back or the way that you can kind of paginate through that data. And then a partition key must be provided when performing queries, so the whole thing must be provided. But a sort key can be partially provided, and that's kind of where the magic of how you kind of iterate or how you can cleverly use the indexes to get specifically the data you want out. So this is how you consider the sort key in terms of both its sorting and its ability to be partially queried is probably one of the biggest things you can do to improve how you retrieve data and out of DynamoDB, both performantly and ergonomically, everything else. A common misconception is that the partition key is kind of the equivalent of a primary key. The reality is when you have a sort key and a partition key together, those are going to equal your primary key. Single table design. So I haven't really talked about that. Single table design is this concept that, unlike a relational database where you might have multiple tables, a table in DynamoDB can be used to store multiple entities. Now, single table design is a fancy way of saying thoughtful string concatenation. Everything with single table designs is going to be a hack. I say this to a lot of people that I've done some consulting with, but everything you do is with DynamoDB is trying to get the most out of your partition and sort keys. And, where you draw the line out on that's too complex or that's not complex, or that doesn't, seem, clean or these other things. What you need to realize about DynamoDB is in order to get the most out of it. And this is, much of this is supported. Look up single table design by Rick Houlihan. He has a great talk on this for Ring. He has a couple talks on this. But ultimately, you're forming strings in such a way to isolate or to cluster together entities of different types inside of a single table. You're doing very similar things to what a relational database would do under the hood, but you're in kind of control of it. So DynamoDB is kind of a weird layer of abstraction where it's fully capable of being made into a very specialized database engine in terms of for your application, you have these access patterns. You have a lot of control over how those things are stored such that you can index and grab them out performantly based on how you store it. And at the same time, it's a very simplistic way of working with data. So it gives you a lot more flexibility by removing a lot of the constraints. The flip side of that knife is that you're not getting a lot of stuff out of the box. So with DynamoDB, you're going to be managing constraints, database constraints that you would have had out of the box with relational databases. So that's, property types for your different fields. Foreign key constraints is not a thing in DynamoDB at all. And in many ways, that's kind of the fabric of the database too. So, it's really important that when you are learning about single table design and you're learning about working with NoSQL of any type, but especially DynamoDB, that you don't just try and recreate the same patterns that you would have had in a relational database, because you really shouldn't grab for a NoSQL database if what you truly need is a relational database. Just grab the relational database. NoSQL has many advantages, but one of those advantages is not that it can be everything for everyone. So I'll move on from there. Single table design, some pros. You gain the ability. This is single table design as opposed to maybe one table per entity. So why might you put everything into one table? Well, you can gain the ability to query across entities in a single query. The con, though, to that is you then share throughput across our entities. So it might be really useful to be able to get, we'll say, orders and the items of the order in a single query. That's great. But if you have, different entities stored in that database that are maybe unrelated that have different throughput concerns, you'll end up sharing the throughput because that's assigned at a table or index level. One of the pros is you'll have less resources to manage, less tables, less expensive, again, less tables. Having things in one table allow you to kind of make more efficient queries, which is then going to be less expensive. And less queries, again, you're hitting the database less, or you're not having to make requests in a series. Maybe you request one thing and then use the results of that to query something else. That's not necessarily bad, but there are definitely times when you might want to optimize that. The con to that, though, is you have more considerations, more complexity, more pitfalls. So, actually implementing single table design is actually pretty difficult. There's a lot that you can make mistakes on, and that's kind of what this video is going to show you is, here are some, basic ways in which you can model your data, and then we'll iterate and improve on those ways so that you don't have to fall in those pitfalls. You don't have to, there's not a big unknown. You don't have to learn from your mistakes so much as you can just learn from mine. Watch this video. Okay, so our challenge, this is the modeling challenge that I mentioned earlier. We're going to model a new technical certification platform, and we're going to design schemas for courses and certificates. These are two entities that we'll store in here, and then we'll just use single table design principles to do it. And then just kind of as a little legend to what we're going to be working on, I'm going to have some code samples. These will be the parameters that you would give to DynamoDB to make the query. And I'm going to show partition keys in yellow, sort keys in blue, and then other keys, other fields, that'll be relevant in gray, just so they don't pop out as much. These, and before I go any further too, this is good for all, really working with DynamoDB in whatever platform. Doesn't matter the language. I mentioned that I have a TypeScript library called ElectroDB. You don't have to use TypeScript or JavaScript or anything to actually get value from this presentation. So this would be true of any language that you use to work with DynamoDB. So let's talk about the course entity. So this is kind of one of the things that we're tasked with modeling. And what is a course entity? So each record of a course entity in our database is going to represent a single instance of a course event that you can attend. So that would be like, if you're in school and you're taking a chemistry class, but that chemistry class is, the 2:30 chemistry class on Tuesday, Thursday or something, right? So it's that particular class that is what's going to represent our row. Not necessarily chemistry, just generally, and then it has different times. This is the 2:30 Tuesday and Thursday chemistry class. That's what a course would be. And in our first attempt to model this entity, our table is only going to have the partition key. I see this a lot. A lot of people, when they first start using DynamoDB, they reach for it as maybe a key value store. And this, by only having a partition key, which is valid in DynamoDB, and there are valid use cases for this, the partition key then is acting solely as a primary key. If you remember, I said a sort key and a partition key together make a primary key. That's if the sort key exists. If the sort key doesn't exist, then it's really just the partition key itself then that becomes the primary key. And then the partition key is named ID. So in DynamoDB, when you create an index or you're creating a key, you also name it. And so in this case, the name is ID. This is, again, very common. What I see in folks who are first dabbling into DynamoDB is that they name the key the thing it's going to hold. So they'll do just a partition key. They'll name the key was going to hold. Maybe it's a account ID or organization ID or any of these things. And that'll be the PK for their main table index. So what access patterns does this get us just out of the box? Well, it really just gets us one, and it's get course by ID. So we got to know the ID, and then we can grab it, sure. But what if we want to grab other things other than this? Well, it gets really hard because we have to know the ID. So a lot of people then just scan the table, and in scanning the table, that's how they get get IDs, all of them. Scanning is a very expensive operation. Scanning is a very expensive operation in DynamoDB. If you can help it, don't scan. But there's a lot of cases for when you might need to scan. You're doing a migration, or you truly need to kind of iterate it over. Maybe you're doing some degree of mass update to properties. There's a lot of pitfalls though with scanning. So if you have a table that's being written to very frequently, well, it's going to be difficult to update an entity or update a table where the values are changing from under it. And the scan doesn't always, it's kind of scanning linearly through your data set. So you could be missing values. It's hard to know if you actually iterated over everything when you perform a scan. Okay, so let's improve on this. And the first thing we're going to do is, and this is kind of the format of this, is I'm gonna take something and then we're going to iterate on it. We're going to make a single improvement. Then we're going to take that, make a single improvement. So the first improvement we're going to do is we're going to look for natural keys. This is something that's very useful when modeling in single table or modeling in a NoSQL database, especially DynamoDB, is DynamoDB gives you the ability to, for instance, have a sort key and as well as a partition key. And maybe, what uniquely defines your data, there's usually an opportunity to allow the data to define itself. So in our case, what might be better for a partition key than a course name? And what might be better for if we're going to be adding a sort key, then choosing the location and start date. No other course is going to have these three things. And as a result, we can use the data itself, the actual values themselves, we can use the actual data itself to become the identifiers for this particular record. So let's take that. We're going to say course name and location and start date. We're going to say, okay, hey, let's put these aside as a partition key and the sort key. This leads us into our next thing. Well, we can't have two values be our sort key, and course name works because that would be the partition key, but the sort key, location, and start date, how are we going to make that work? Well, what's really common with single table design, and it's actually probably just, even if you're not doing single table design, I can't recommend this enough. Make attributes that are the actual key values. So for instance, for the main table index, if you have a partition and sort key, make a PK and an SK field and make those the keys. Don't call it account ID, or don't call it user ID, account ID, or these other things. Because one, if you're doing single table design, having it be generic is important because it won't actually map to that thing. And two, even if you are doing single table design, naming it what actually holds creates a really rigid model for your data. It doesn't allow you to, change or kind of fluidly update how you're storing the data, unless you like the idea of, it's like, oh, that field that's really organization ID. It's called account ID because we started with account ID, and now we actually just store the organization ID. It's like a story is all the time. So just keep it really simple. Just call it PK and SK, and store those values separate from the attributes itself, especially if those attributes are included in the actual key itself. So what we did is we added PK and SK here, and we moved course name directly into we put course name into the PK. Notice course name is still here. And then we take location and start date, and we put those into the SK. We just concatenated them. So PK is a direct duplication. Yes, it's true. It's a direct duplication of course name. And SK is just a duplication of start date and location. But this is a really powerful technique with any NoSQL database. Really, it's just denormalization. You kind of have to, in a relational world, this would have been sacrilegious, right? Because you're storing the data twice. But in NoSQL, denormalization is probably one of your most powerful techniques that you can use. I encourage you to take a look into it. But again, yes, it's true. These are duplicates. But this is good though, and you'll see why. We'll keep moving on. The next thing you want to do is, how can we improve on this? Well, the first thing we can do is we can remove spacing and standardize the casing of our values. So when we're dealing with natural keys, what's going to end up happening is you want to reduce the burden of the caller to have to know information. That's just useful in general. Even if we weren't creating these composites, there's 2 SK values in one, or anything else like that. Or and even if we weren't doing denormalization, to be honest, standardizing the casing and the spacing removes a large bit of information that the caller will have to know. So if we wanted to find intro to DynamoDB, all the courses by that, right? Again, we can give just the partition key to DynamoDB, and it will find all of the associated records associated with that, because you give it the partition and it will say, oh, you don't have to give it a sort key. We'll give everything underneath that partition. Well, intro to DynamoDB is, as it's stored and displayed for the user, has a capital I, spaces here, DynamoDB, capital DB at the end. Well, that's information that the front end is going to have to know in order to make the query for this. And by the front end, I just mean whoever is calling. What if by removing the casing and then also removing the spacing, that's information that the caller might not have to know, or they could get wrong, and it's fine. This is actually one of the core reasons I said I'll probably call back to this a couple times. This is one of the core benefits of having a field separate from the value that you're actually trying to utilize here. So course name, it's casing and spacing are exactly how you want it displayed. But when stored as the key, we can start making changes there that help with the actual queryability of the values, that help actually make the data easier to find or to update or to maintain. But we don't have to change we don't have to actually change the way that it's displayed as a result. That'd be lossy, right? If we remove the spacing and casing for PK, what would end up happening is we would have no good way of actually displaying that to the user. They would look at this mess and be like, what does this even say? But again, this is for the computer to read. This isn't really for us to read. And you would have some functionality that lower cases in, remove spaces and things like that. So you also don't have to worry about it. But that's why removing spacing and standardized casing is being really helpful, is you reduce the burden of the caller to have to know things like, what is the case of DB at the end again? Is it capital D, lowercase b, et cetera, et cetera. So let's improve on this. So we just improved on it by the last step. Now what we'll do is we're going to add delimiters after each composite attribute. So PK is just one attribute, but we would do the same for PK. Sort key is where it really matters, which is before you can see, we would have the building ID would butt up right against the year, and that can be difficult to read, but again, it's computer reading, it's not a big deal. But the new version now has a delimiter, and we're using a pound. This is a very common delimiter to use in a DynamoDB key. It's nice because it's high in the sort order, so it serves a purpose, and I'll go into that. Why delimiters matter. So this might actually seem arbitrary, but it's probably one of the more important things that you can do. I'm going to talk about a situation where we have a composite of our sort key of city, state, and zip. And what we'll do, these are the values. We'll say that this is part of a partition key. These are the values that somebody has provided. And what we'll do is we will concatenate these and standardize on case and remove the casing. And what we're also going to do too is we're going to reorganize these. I think it's in DynamoDB, because of the unique nature of the sort key impacting the order of results that come back. And then also the fact that you can provide a partial sort key. So you could say begins with, or greater than or less than. So you can provide, just the word Wyoming, for instance. What really becomes helpful is to create hierarchical keys, to think about keys, and I'll come back to this too, in terms of thinking in terms of sort and thinking in terms of partiality. It might be, in regular parlance to refer to Jackson, Wyoming in a zip code. But when it comes to being able to provide something partially, thinking about things in terms of hierarchical values. So Wyoming is, if you just said begins with Wyoming, you'll get all cities that begin with Wyoming. If you just said begins with Jackson, well, there might be a Jackson in Wyoming, there might be a Jackson in, Maine and, Ohio or any of those places. But is that maybe really what you want? Are you starting at knowing the city? So start broad and make things more simple, or, does one encapsulate another? Now, it's totally valid that maybe Jackson, then Wyoming actually makes sense for your access pattern. But for ours, we're going to say Wyoming, then Jackson, then zip code. So let's get back to delimiters, though. I mean, that's what we're really talking about here. So this is kind of what I was talking about. I'm glad that I remember this presentation. I guess so this will be a rehash. So if I said begins with Wyoming, that's going to be really nice because I'll start to get back maybe Cheyenne, Wyoming, or Jackson, Wyoming, Laramie. And these have different zip codes. That's really, really helpful, right? And now I'll say Wyoming, Jackson. Great. I'll get, oh, wait, that's right. I was going to say, I'll get all the zip codes in there. But no, actually, what we might end up getting is Jackson and Jacksonville in there as well. And this is really common. This is definitely one of the bigger pitfalls that people run into, is they see the power of using begins with. I'm like, oh man, if I can do, country, state, city, or country, state, county, city, zip code, or whatever, and I can really slice and dice the data that comes back. Well, one of the things is they don't have delimiters, and as a result, they end up over-querying. So how do we fix this here? Well, we can add the delimiters that I mentioned. And so what that looks like is you do begins with Wyoming, Jackson. That, if that's valid, which there are definitely web apps or definitely scenarios where you'd want to include that. But what if you really want to only include zip codes inside of Jackson, the city of Jackson? You would then be able to then tack the delimiter at the end of your item. And what that would do is the only thing that's going to return is just only zip codes inside of Jackson. So that's why the delimiter ends up being really helpful, is when you're doing a partial query, again, you can either omit the delimiter and kind of get things back that are, Jackson inclusive. And so again, there's maybe values, there's maybe value to that, where it's maybe not a partial word, maybe it's a numeric value, and you just want anything after that. But if you do want to cut it off and you say, okay, well, I don't just mean anything that starts with Jackson. I mean anything that basically is Wyoming and Jackson, nothing beyond that. Adding the delimiter at the end, the trailing delimiter at the end of your begins with queries, or your other, betweens or greater than, less than, equal to, any of those, really can narrow down the use of your index, and you end up iterating and having to filter through a lot less data. Which, again, it can also go through, if you over a query, you have the potential, depending on how your keys are set up, you could actually leak multi-tenant information. I mean, it could be bad as well. So it's not just that you're maybe returning too many results and, the user just gets back things that isn't relevant. It could be worse. I mean, it could be a scenario where you're showing them data that they shouldn't see, or you're providing them with, values for another customer, or you're providing them with values for another, internal account that you have. It can result in data leakage, and it's no small thing. Okay, so I just went over, and I just went over way too much with delimiters. So let's move on to the next one. Another thing you should do, and this is something that you don't want to necessarily learn the hard way, is zero padding any numbers that you might have in your composite attribute. So in this case, we have building 1. And let's say we know that our campus or something has, there's upwards of we'll say 50 buildings or something. And we call them building, 1 through 50. And if it's a little bit more unbound than that, then you can have a slightly different rule. But we'll say that, we know it's going to be in the double digits. We don't really anticipate ever having, or maybe the value is like 10. We have 10 buildings. It's not like we're ever going to have 100 buildings. If we do, we have other problems. The important thing, though, is to zero pad the numbers in which you might have a discrete range, or at least an estimatable range. And the reason for that is because when your sort key is a string, which arguably I'm always going for a string sort key. I like the fact I can store a lot more data into it. I'm not limited. But if you have a string sort key, then numbers are going to be sorted in lexicographical order. So building 1, if you said greater than building 1, for instance, again, we're doing a partial sort key. If you're saying greater than building 1, then what's greater than building 1? Well, building 1 is building 10, building, 11. Basically, if you don't zero pad, you're going to, again, kind of get records back that you're not truly expecting, or buildings greater than 2. Well, 10 is less than 2 if you look at it lexicographically. So zero pad that wherever you can, if it makes sense. And then the next step after this, if we make another improvement, let's compose the attributes by hierarchy. So this is something that I already mentioned in the Jackson the Jackson example, but this goes for items. This goes for dates. Dates are a big one, so I highlight this here. It might make sense to display to the user, the month, day, year format, because that's how we want to display and that's how it's stored, because that needs to be human readable. But when it comes to value in our sort key, again, another example of how having an attribute separate from the attribute that stores and displays the data and holds the business value. Our keys should be representations of the best way to store the data for indexing, for sorting, or for being a partition key. And so what we'll do is we're going to flip the date to be a hierarchical format. This is just UTC date format. This is super, super helpful with dates. I think you should always do this with dates and to use an ISO format if you're not already. But again, when you think about the order of, or the sort key, you got to be thinking about order. You got to be thinking about hierarchy. You have to be thinking about, hey, if I were to provide this partially, is it more important to me to see things by state or by sit? If usually you start broad and get more specific if you're trying to think about how something might fit into hierarchy. You also got to be thinking about the fact that when these records are sorted next to each other, is this value, I'll need to provide the value before it. So am I going to know that value, for one? In this case, we're doing it by date. This likely makes sense, right? Is it more important that we're looking for, or is our common access pattern, is it by looking at courses that are coming up? Or is it by looking at courses associated with building 0-1? In DynamoDB, we have secondary indexes, so we don't have to choose just one. But between those two options, again, we're just talking about one partition sort key here. Probably more likely in a scenario where you have courses and you have kind of like this system of looking at courses to know courses that are upcoming or courses that happened in the past, very date oriented. So having the date be the first in the two composite is likely the better choice for how you might access the data. You want to find things that begin with the year 2022 because you want to see 2022. This is when I gave the talk, 2022 courses. And, it's very unlikely then in that case that one of your primary access patterns is, well, where are all the courses just happening regardless of time at building 0-1? That's probably a more niche access pattern, certainly one that could exist, but probably not one that we would want to make as the one and only access pattern that we support. Okay, so let's reflect on some of the changes that we made so far. We're going to say get course by ID. We still have, that was the one that we had before. That was the only one we had. And we still have that, only now in this case, it's going to be get course by name, date, and location, because that's going to be the individual course. That's what defines our individual course. So if you want to open a specific course, you got to know at least those three pieces of info. which again, if you wanted to, you don't necessarily have to know those values individually. Maybe you put that into a string yourself or something, you pass around that concatenation of those. But the idea being that you'll need to know those three pieces of information. That's more than knowing just the ID. So it's definitely shouldn't be lost on anybody that, you did make a bit of a compromise there. You went from having, one piece of information to three. Let us see what else we got by doing that. We're going to have get courses by name. So find me all the courses for Intro to DynamoDB. That's useful for when you are, just trying to find a instance or you're trying to find a Intro to DynamoDB course that you can attend. Get course by name, Intro to DynamoDB, and year. And get by year and month. Maybe by year, month, and day. So these types of things make use of providing a partial key. You can narrow this down and really hone in on exactly, when you might try and register for a class or when a class occurred or courses that occurred during March of 2022. Notice at the end of this query, I tacked on a hash. And then what about another one? Keep course occurrences by name, date, and partial location. So the location itself could also be partial. Maybe you want this day, but you don't care which building it's in. So I'm saying, okay, sweet, this course, this date, any building you got, or maybe you have buildings and you also have some other, place that something could be, maybe library or something like that. Well, I can only go to the buildings or something, right? So maybe it's part of the location that we need to go. And then eventually you can it goes back, you provide everything that goes back to get course occurrence by name, date, and location. Okay. Now we're talking about single table design. So we're going to also have another entity that lives inside of this table. And we're calling this the certificate entity. Now the certificate entity is going to be very similar to the course entity, because what we'll say is the certificate entity is one that you get when you complete the course. So you took the course Intro to DynamoDB, you got a certificate for that course. So it's definitely tied to the course that you took. You can see that's very similar. We went ahead and we're skipping over some of the basic stuff that we went to. The PK is going to be the course name, same as the course entity. And then the sort key is going to be very similar. So that this part's the same. The sort key is going to be very similar in the sense that it starts with the date, which for the certificate entity is the issue date. The course entity is going to be the start date of the course. But on the certificate entity, we have the student as the second piece of this. So the student being, in this case, David Spurdy. I will mention this. This is an aside in this presentation. This is a good example. We could actually flip David Spurdy and make it Spurdy David inside of the SK. That would actually be a good choice too. I had somebody bring that up and I gave this talk once. That's absolutely correct. If it's a useful access pattern for you, if it's useful to be able to say, oh man, there's so many Davids, start with so many people with the last name Smith. I need to know all the Smiths that were in this. It might be more useful to see everybody with a certain last name than it is to see everybody first name. Or in this case, maybe it doesn't matter at all. So what really matters is just that they have their unique name there. This obviously is something where, two people could have the same course with the same name. This doesn't account for that. I think in a real production system, that's something you have to contend with. But in our example, it works out just fine. So again, very similar keys. PK is going to be the same. They're both going to have the date. And in our system, a certificate, you're going to be given that the same date you complete the course. But then course entity has a location and certificate entity has a student. So they're not actually going to collide with each other. We're also assuming that students' names aren't the same as locations, and vice versa. But let's see what happens here. So we could provide with this, when it comes to the queries that we can perform, we could say get all courses and associated certificates by the PK. So we can just provide, because they share the same partition key, we can provide just the partition key in a query. PK equals Intro to DynamoDB. And we're going to get back all courses and associated certificates. Furthermore, we can make another query that just has the PK and then the partial date, either some of it or in this case, all of it. So that would be all courses and certificates by date. So everybody who actually got a certificate which might be different. There might be individuals who took the class, who didn't get a certificate, things like that. We'd be able to get all those back in one. We basically, what are the certificates that came from this class is kind of how you might be able to see this. And again, that's not including the building. So to the extent that you can use an index, one of the pitfalls, this is kind of another aside, one of the pitfalls that you kind of oftentimes see folks coming in, they're really excited about the fact that they can create these keys and do all they want. At the end of the day, using the index as much as possible to narrow down the funnel as much as possible is the goal. But it's not always possible that you can do everything with an index. So, for instance, if you just want to see all course and certificates for building 01, and you want to get all the certificates for it too, well, you can't really, if you included building 1 in what you provide, you're going to end up removing the certificate entity from your query, because none of the certificates start with building 01. And that's fine. Again, like the amount that you're able to leverage an index, you should really just consider like, how can I get this down to the most finite point possible? And then additionally, you might need to add more filters to the query itself. DynamoDB has some filter built in, or in your code itself after it comes back. But the idea that you narrow it down to the place in which you can the most, and then you might just have some additional work. That's totally fine, and that's totally valid. It's not always going to be super clean that you are able to just only use an index and nothing else. That's not always how it works out, and that's fine too, because again, you are building your own little database engine. So, you might reach out for some, have to still process the data a little bit, and then return. Another approach is maybe you leverage the index to get everything for building 01 in one query, and you run the same query. So you actually run two queries, one for certificate, one for course. That's just as valid as well, and it's up to you to determine, okay, what's the trade-off here from maybe a performance standpoint? If I make two calls like this, am I hurting my throughput? Is my throughput too much for that table for what I'm paying for? Or is the response time just not fast enough? Or, is it easier in my code base to make one query and then deal with it? Or is it easier in my code base to make two queries and then do any post-processing after that? It's going to be totally up to your implementation. But ultimately, you just want to use indexes as much as you can to narrow things down as much as you can so that you don't have as much data to process if you need to. And you don't have to iterate over, it's not just about overquerying, it's about underquerying. You have to make more requests to get what you want because you're not able to leverage the indexes you need. The last thing I'll say about this in general, this is kind of the core pieces of single table design in the sense that it's all about compromises, and you'll get the most bang for your buck if you look at it this way. You should look at your access patterns on how common they are and ensure that those common access patterns are probably the simplest to achieve with your data model. You're going to have more complex access patterns, and the complexity that you will inevitably have, maybe try and orchestrate it so the complexity is associated with uncommon queries and the simplicity of your model associated with your common queries, so that you can do what you need to easily 90, 80, 60% of the time. But when you start getting into waters where you're trying to do edge cases or you're trying to do very specific work, embrace the fact that, you can't make everything simple, and not everything is going to be the most performant or the most clean. I hear a lot of stuff about, these clean approaches. It's to taste, so your optimizations are going to, by the very nature of what an optimization is, you're going to have drawbacks in some cases but better benefits in other cases. So keep that in mind as you're designing your keys. Know that you can't do everything with a key. You're going to have some compromises, and that's okay. Just make sure the compromises bode well for your common access patterns. Okay, so there's actually still more to this, believe it or not. Let's see if I can still get through it. So the entity isolation, the concept of entity isolation is probably one of the biggest ones with single table design. So, you you've done the work, you've made keys that are really useful. I still actually have some more key tricks up my sleeves, but entity isolation is something that a lot of people don't consider at the very start of starting with DynamoDB or starting with single table design. But it is honestly the key part to get right with single table design. When you think about entity isolation, you're trying to prevent records from leaking from overquery, or you're trying to optimize for precision with your queries. So there's two ways you can look at it. You can optimize your keys and your queries for, again, precision. So I'm trying to find these specific things. I have 1 million records, and when I query it, I need to actually get it down to 100. Like I'm looking, my access patterns are that, I store a lot of different things, but when somebody goes to a particular page, I need to be able to get all that stuff for just that page performantly and easily. It's less important that you see the million and versus you being able to key off of what you need. And that's one side of it. So it's always going to be a tug and push-pull between optimizing for precision, if that's what you need, or optimizing for cross-entity joins. So by this, I mean, with single table design, one of the benefits to it is that you can query multiple entity types or multiple pieces of data. You can query if you're querying a page, well, you can, in the same query, return back all the comments for that page. And they're both located around the same thing. In our example app, we have the course and all of its certificates. So the course and certificates, those are entities that we care about together. We go to the course page and we want to see all the certificates on that page. We have some sort of administrative backend or something. And so it's important for us in certain apps to be able to not just say, give me data about this one thing, and I just want to find this one, one type of thing. I just want to find just courses. That's precision. Cross-entity joins is I want to find courses and related data easily. Now, I'll go into how these things end up kind of being a push-pull together. And to do that, we'll just only talk about the keys here. So one of the things that we can do to impact isolation is using static key prefixes. So what does that actually mean? So by adding static strings into your keys, it allows us to change the order of sort or change how these entities are grouped within a partition. Because things are in a partition, things are sorted by the sort key, so they are logically kind of grouped by alphabetical. The A, things that start with the letter A are next to the things that start with the letter A. And previously with our other version, things in 2002 will be next to things that are from 2002. So when we perform a query, we say, PK equals DynamoDB, we're going to go, that has the advantage of allowing us to query by date effectively. And it'll be in chronological order. Stuff in 2002 in March will be next to the stuff by March, and which will then also be next to what's in April. These static strings, and I call it this because this is not necessarily data that the caller must know. This is data that the, whatever service you've written to query DynamoDB, it would know this. So nobody has to provide this other than that caller. So if you have a service fronting DynamoDB, nobody has to pass this cert value. It just says, no, when I'm making this query, I have cert in the key structure. So unlike a composite attribute, which comes from values itself, this is just static, in this case, a static prefix. So where you place this value, this is a very helpful technique for isolation, impacts those access patterns. For instance, we could put it here at the very beginning, and what that would have the advantage of doing is putting all certs right next to each other. Instead of sorting by date first, it would sort by all certs next to each other first, and then it would move to the date. It would have all certs next to each other, and let's say we also have those courses, right? Assuming course has course instead of cert, all the courses would be grouped next to each other, and all the certs would be next to each other. Within the cert, alphabetically, you could assume then that it goes to then the year and the month and the day and those other things that apply. Another approach to this is to put cert maybe somewhere in the middle. And what this would allow us to do is now certs and certificates and courses are sorting right next to each other by year, month, and day. they are sorting next to each other by that. And then after that, they are then kind of apart from each other within that month, year, and day between cert and course. So you can visualize this. One of the easy ways to visualize this is if you put values into maybe Excel and then you sort the values in Excel. Or you could also, this is, you do this almost every day if you work with just your folder structures, the name of the folder or the file. You can think of hierarchical keys as the path of your particular file. So when you name something, you're all, especially if you have a directory with a ton of files in it, if you've ever had to, kind of organize yourself and be able to find things really fast, you've had to start thinking carefully about how you name things because of how they sort, how they're next to each other. If I want to find one thing, is it close to another thing that I want to find as well? The further away it is, the harder it is to access it. Maybe that's not a problem for some things because they're unrelated, but maybe it's easier to have them next to each other because you're always trying to look for both at the same time. So the location is going to be unique to your individual use case. But this aspect of where you might put a static prefix or a static string is super powerful in helping you isolate your queries. Because again, if you put it at the beginning, now certs are going to be next to each other. It's much easier to find specifically certs or specifically courses. That can be really helpful if you don't want to find certs when you're looking for your courses. So what this kind of looks like is the further to the left that you might put a static string is going to optimize for a high volume of records per partition. So what do I mean by that? Let's say, intro to DynamoDB, maybe we have a different partition key. Maybe the partition key is organization or something, right? Or it's going to be a category or something, right? So you're going to have a lot of records. Intro to DynamoDB, maybe we'll say that there's like thousands of classes and there's thousands of courses and there's millions of students or something like that. And so that partition key has a ton of things underneath. Well, it becomes really important to isolate specifically what we want early in our query. So when we have a partition key that just has a ton of records in it. And so having a static string that's further to the left helps us in that situation where we have a high volume of records per partition and we want to instantly start narrowing it. So we have millions of records underneath each partition key, and we just instantly want to just zero and hone in on just certs. Well, we would put it at the start. And then the opposite is true, is the further maybe a static string we put to the right, maybe we want to there's a high relationship density per partition. So for this type of index, we care about the connectedness. Maybe for each partition, it represents a single screen that we have on the partition key is the screen that something is going to apply on, like it's a product. The product is that, and we want to see all the data associated with that product under there. And so we have a lot of related data that's purposely related, that's going to be queried together. It's living together because it wants to be queried together. That's why we put it under a partition key, and we want to get all of it at the same time. You can put that further to the right. And what that will allow us to do is it just allows, in this case, cert is kind of the type of entity it is. By putting it further to the right, we're able to then leverage just the partition key or maybe partial sort keys to get back more than one entity. So this is kind of the big push-pull that doesn't get a lot of discussion when it comes to most single table design, but I think it's really pivotal is to think about, am I trying to optimize this index for high volume of, for narrowing down and for isolating entities, or for clustering entities together because they're related? When you optimize for one, you kind of de-optimize for the other. So if you're optimizing for high relationship density, it becomes harder for you to get specific data. It becomes harder for you to get certs because now if you want to find a particular cert, you have to pass the full date. You have to kind of iterate through the dates to find it. Now again, depending on your access pattern, you might always be, you want to find things that are related. But if you're only trying to find a cert because you have to open that cert page or things like that, that can be really hard because now you're iterating through multiple different entity types. And again, the flip side is true for the partition, high volume of records per partition. if you're trying to find related data, where you're going to have to perform a lot more queries if this data is really disparate. If it's really isolated, you might have to end up making multiple requests to the database, which is going to add duration time to the requests that you can serve that data. Okay, that's enough on that. Entity isolation, another concept here is versioning. And what I like to do, my keys, shout out to ElectroDB. It does all of these things for free out of the box with no configuration. It adds adding a version number to our static prefix can be really helpful. And so the static prefix or static string that I most often use is my entity, or sometimes I'll go beyond that, not even just my entity, maybe some sort of subgrouping that helps me group things even further. And you see this in ElectroDB's book. You might see, it's user, and then it's the user's ID. So it's not just the ID, it's user hash ID, or book hash ID, movie hash, title or whatever. What can be really helpful though is if you also throw a version number in there, and the version number is going to be the version of your entity. And so this can be really helpful when you're doing migrations. It could be really useful to ensure that you're correcting or querying the correct entity version. So when you're, if you've migrated, you're like, oh, the V1 version of my entity is not really correct. I need to use the V2 version. That, you can, they might have different shapes. In V2, you started calling name display name, and you started calling age became or birthday became a different formatted string, or as opposed to a date timestamp or something. These types of things matter, and by having a version number, you can also via the key isolate just the version of the entity you want. Again, that's really helpful in migrations. And so, for instance, if you're trying to migrate 0.1 entities over to 0.2 entities, this can be really helpful. If you want to say between versions 3 and 4, because you're trying to migrate over to version 5 of your entity, you can do that using the indexes. And it becomes really helpful because, again, anytime you can avoid using a scan, you're going to be better off, because if you're scanning over large bits of data, a lot of times you might have to rescan to make sure you got everything. It can really help you to performantly migrate in place. Maybe you're querying, you're serving real traffic, you're serving version 1 and version 2 entities. You're just kind of in real time, kind of upgrading version 1 or mapping version 1 to version 2 values. Maybe you then, as a result, you queried both independently, and you can, or query them in the same request. For instance, here, you can see in this case, if I wanted to query both, I could simply use the year cert and do it begins with cert, all of this cert hash, and I would get version 1, version 2, version 3, all these other versions. Get those back, sort it in my code, do what I need to, return it back. That becomes really helpful. Okay, another, would you believe it? There are still more things here. I've been doing this too long. So sharding is a super, super helpful technique with the problem experienced oftentimes in DynamoDB, which is hot partitions. Now, hot partitions, you'll hear and you'll see, hey, they've done a lot of work on it. They're solving it. They've solved it in many respects. But there's only so much that DynamoDB can do, and there's also drawbacks to even their mechanisms to help with hot partitions. You still need to consider how the data is stored in your database. Otherwise, you can very easily run into various throttling issues. You're going to be only as good as basically your weakest partition key, because when you're updating, let's say you're creating a bunch of entities or you're deleting a bunch of entities, once you start having, GSIs of different types, it's your weakest partition key that's really going to hurt you the most. Because while every index has its own throughput, if you're creating an entity, while you're creating a GSI and you're creating a main table index, the rate in which you can do it is defined by your worst index. So your worst performing index. So let's talk about just the GSI for a second. So we're going to walk away from that PK and SK. Now we're dealing with GSI 1 PK, GSI 1 SK. This is the generic name I'll give to our partition and sort key for a GSI 1. People feel very strongly lean against this naming oftentimes. And I say to that, I say, just grow up. Just grow up. It's like, it is what it is. It's for a computer to read. It's not really for people to read. So in this one, let's say we went with the certificate type. This would be I think what we can do here is cert type in the instructor, because what we went with. So in this case, the cert type is completion, and then the instructor is title Walch. Hey, that's me. And then in this case, we went with a leftmost oriented static string and the version. So that's still there from this because it's the type of entity, it's a certificate. So this is going to allow us to basically find completion certificates for a cert and say maybe like just the V1 cert entity. And we're putting those in the GSI1 PK, GSI2 1 SK. Grow up. It's a great name. It's generic. It's fine. Okay. So I mentioned this already. The put, delete, update, throughput could be throttled by your weakest partition key. That's true whether or not they're working on hot partitions or not. You still have to consider that. And then one of the ways in which you can accomplish sharding. So again, PK is the cert type and SK is ultimately just the instructor. Is you can create a function and however this is a pseudocode, but create like a shard ID. What you might do with that is you come up with a deterministic way to get a numeric value for your short key value. In this case, the instructor, right? Or just the instructor name. And in this case, this function here, I'm just taking the UTF code points for a particular string, the instructor name, and I'm giving it to modulo 20. The idea being that it will spit out a number between 0 and 19, and that will be my shard that I will write to. What I'll do is I'm going to take that shard and put it into the partition key, and that will then add that will distribute that partition key of completion now across 20 different individual partition keys. So I took something like completion, which is like, everybody who's going to have a certificate of completion. I mean, there could be millions of those, right? So that becomes a really hot key. But if we add this sharding technique in which we take the sort key value, in this case, the instructor name, or maybe it's in our previous example, I think it was the start date or the issue date. It could just be the issue date, or it could be the issue date and the student name, and we get a shard ID from that. But because I've taken that, now completion has basically, it's spread across 20 different partitions. And so while before it was maybe, we'll say 100,000, or we'll say 200,000 because it'll be easier for me to do in my head, 200,000 completion certificates under one partition. Now it'll simply be, was it 10? I thought it was going to be easier. 10,000 completion certificates per partition key, because there'll be 20 shards. And the beauty of this too is first you're looking at it and you're just like, well, I mean, what good does that maybe do? Well, the good that it could do is a number of things. One, you can query multiple completion. You can very quickly and easily divvy up this work. You could send out 20 requests, and basically 20 separate requests to iterate across all your completion certificates. If you need to get them all very quickly, well, the upper and lower bounds, right? So you can say basically, give me completion. You can make your first request is completion certificate completion hash 00, the hash, and that's the partition key, and you can iterate through those. Concurrently, you could iterate through 1 through 19 as well. So 0 through 19 concurrent requests. That's better than you could do with just regular completion, because with completion, you'd have to iterate basically through all of them in a serialized way. It would be request, wait. But this one will allow you to do them all in series or concurrently, not in series. And if you're looking for something in particular, let's say you can always query it. You can always provide the full thing if you know the instructor name, which you can, in this case, is going to be the title Walch value. you can arrive at the fact that that comes out to be 18. The one thing that's difficult is if you don't know the full partition key, maybe, again, we had issue date and then the student's name, right? If your shard ID is based off of both of those together, then you can't just say, completion date, you can't really fully create a completion date without both of those values. So you can't really do a starts with date on those. But what you could do, and this is what you would do in that case, is you could start with 0 and basically say partition key this, 0, completion, hash, 0, and with a sort key that starts with this date. And then you may or may not get back some values, but you're going to have to kind of then iterate. And then once that comes back with nothing, then start at completion 01, completion 02. So again, and that's really just mitigated by doing parallel queries at that point. So this is a really powerful technique. So don't sleep on this. This is something that a lot of people will wish they had done earlier, which is, again, if you have a PK that doesn't have very high cardinality, in this case, really consider sharding as a good technique here. Even if it does have a lot of cardinality, if it has a lot of values underneath, it could be, a lot of, I keep finding ways to add to this, but I've seen a lot, you could put something like I've seen folks that have account ID as the partition key, and that's a GUID. So that's about as high cardinality as you can get, right? But they have just so much data underneath account ID that then in those cases, having a shard ID becomes super helpful because they go to update it. You run into these throughput issues because you end up touching so much data underneath one partition. It can really cause Dynamo to either slug or you just start having to rate limit your own applications because they're trying to operate too fast on a single partition. So where does this get us? So let's go over just some final access patterns. That's pretty much it, if I remember right. Again, it's been a while since I got through this presentation, but we have get certificate. This is, you provide you have the certificate name, the issue date, and the student. So you just provide all of these. Your application will add cert and 01. So you don't necessarily need to provide that as a user, but if you are a user providing this, you just know those 3 pieces. You can get certs by date, but that's actually not certs by date. Callback, it's actually going to be certs and courses by date, but using the delimiter, we could and by having the static string, now we could get just certs by date. See how that worked? Certs by entity version and the date. A lot of times you'll just end up including the version no matter what, but there's reasons why you wouldn't. Over. And then we also have getting all completions. So again, we can do them parallel if there's a shard ID in there. Just give me all the completions. And give me all. Completion might mean, I'll say this, completion might mean that there's other things that qualifies it as a completion. This is something that you can leave the door open for. But we put the cert at the start. So the user might have provided, hey, give me completions here. But the endpoint then can add the static string of cert hash, and now it doesn't matter what anything else has if there are other things that use completion, because you'll just only get certs back. And then the V1 certificates, just to give lip service to that again, and I get all completion dates, certificates taught by Tyler Walch. This is something you could use to get a whole slew of, just for a particular instructor. So that's pretty much it. Like we started with, basically just a single access pattern. We added a whole crap ton of them and went over a bunch of pitfalls. Hopefully you found something useful in this that you hadn't heard before, hadn't considered before. I've been thinking way too much and too long about how things sort and how, the little minutiae of things that end up making a big difference when you're at scale. The thing about DynamoDB is people give a lot of lip service to the idea you got to plan your access patterns at the start. To that I say, no more than any other database, you have to plan your access patterns from the start. But what's different with DynamoDB is when you go to migrate, you don't have, SQL tooling around that. You have to write your own tooling. So the consequence of not modeling or thinking about these things or giving weight to something like a shard ID, or you could easily dismiss any one of these steps that I showed. But when you go to migrate it because you feel the pain, that's when you'll have that sense of regret. Like, oh man, okay, I can see why now. This is, this little bit is costing us a lot of money because we have to over paginate now because we missed out on this one thing. And to migrate it, we have to go through and update whole, thousands or millions of records. So consider this, and also shout out again for ElectroDB. Check it out, NPM. My name again is Tyler Walch. You can find me on Twitter under Tinker Tamper. You feel free to shoot me questions or anything else about anything I went over.